Welcome to my Texas workshop. I'm Randy Lammers.
I'm Aaron Keevan.
This is worth knowing. We're very excited to continue our series on clamp load retention. And what do you do when just torque to load is not enough? But more critical, what about when you have really important joints that are maybe safety critical, Aaron?
Yeah.
They have to stay together.
Warranty issues or high vibratory applications.
Absolutely.
What kind of product do we have to use in this?
We have something today we want to talk to you about called a wedge lock washer. And we're very pleased to introduce our guest, Luke Reed from HYCO Fastening Systems. Thank you for being here today, Luke, in our Texas workshop. And tell us a little bit more about HYCO and about the product that you manufacture.
Randy, it's great to be here. Thank you for having me. HYCO is a 120-year-old German-owned cold forming company.
Okay.
Manufactures various fasteners, and the wedge lock washer is kind of at the apex of our industrial bolting line. So yeah, we're excited to be here and talk more about this technology.
Absolutely, we're excited for you to tell us about it.
Yeah, so where do we see wedge lock washers actually used?
Well, the categories are endless. But you touched on a great point earlier about the critical application, the critical bolted joints.
Right.
So we can discuss on and on and on about folks that where it's applicable to have a wedge lock washer. Today, renewable energy is a big category that we all hear about. That's certainly a growing industry.
The wind industry?
The wind industry in particular.
Well, lots of vibration going on there, and we can't have anything come loose on those wind turbines, can we?
No, we can't. From the ground level all the way to the top of the nacelle.
Yeah.
You've got thousands of bolts who face high vibration, so even some shock loads.
Yep.
So that's a great number of applications in the wind business. From the nacelle, foundation bolting, the blade connections, platform, in the tower and ladders and so on and so forth. So great user of this technology, but also in renewables you have solar.
Right.
Solar applications, long lifespans, 20, 25, 30 year commission rates. So you have a lot of wind loading. And those critical bolted joints there need to be secured for the life.
Thing.
Yeah, you wouldn't think about wind loading. We're talking about using the sun to gain power, but
That's right.
You've got to worry about dynamic loading in this situation.
You have to, because you don't want to have folk going back 5, 6 years later having to retorque thousands of bolts in your
Very
standard
expensive.
wind farm.
Correct.
So yeah, those are two primary categories for this technology today. Also
I believe
military.
you mentioned military. Yeah. So military, I can't think of anything more critical than really protecting us on a daily basis. We can't have our military out there repairing equipment out in the field because they have torque wrenches on them.
Well, no.
Okay. So it has to be right, and the retention has to be there.
Well, you have high vibration, you have shock loads,
Right.
Everything from the off-road vehicles to gun systems. I mean, the list goes on and on. Even today with drones, drone technology, the transport drones, there's a lot of critical bolted joints that you don't want to fail.
Right. So what we want to tell you about today is, and this has been proven out, obviously, as Luke has just told you, in some very high critical applications. So let's take what was proven out there and bring it into normal industry and applications that are coming loose on a daily basis. I think you're going to find the wedge lock washer is good for that.
Right. And we're talking about bolted joints here and overcoming our friction, making sure that we're putting insurance into these critical bolted joints. So what are we talking about here exactly?
Yeah. So why do joints come loose? Let's just start with that one. So why do joints come loose? Luke, you've got some good explanation of that. So let's talk about what are the issues that we deal with on a regular basis.
Well, bolts can come loose for a myriad of reasons. You have high vibration or transverse or shear loads. You even have elements with the with the tensile or the strength of the fastener.
Right.
Corrosion.
Right.
So it just goes on and on. So there's generally two modes of bolt failure. You have overloading and then loss of preload.
Right.
So for this application, and today we're talking about loss of preload.
Okay.
So how do you prevent the clamp surfaces from losing their friction forces and being subjected to a shear load? And how do you prevent that?
That's that transverse load
Right.
that
Moving
we're
against
talking
each
about.
other.
Right.
Yeah.
Where we get a load like this. So there's actual loading like this. So maybe that's more like spring action
more axial.
that's taking place, more axial. and then you have transverse. It's the transverse loads that seem to cause the biggest problem, and that's where this wedge lock washer really does a good prevention of that.
Absolutely. You have to maintain that preload to keep that joint tight.
Absolutely, absolutely.
So we talked about performance, safety, and downtime loss of revenue. So some of the other influences that we have, outside influences on bolted joint failure, what could those be?
Well, you can have a singular effect, a vibration only, impacting on a bolted joint.
A shock.
A shock.
There you go.
Yep.
Okay.
So these are dynamic loads that are being subjected on the.
Thinking
on
of
the
my
bolt.
tractors.
That's a great thing to think about.
Okay.
And for you, that's a critical bolted
That's
joint.
critical to me. Absolutely, it's critical to me.
So, but you can have multiple influences.
Mm-hmm.
You can have axial influences due to cryogenic environments or hot and during the day and nighttime temperature swings in the desert, for example. So you've got the bolt actually potentially moving.
Right.
And then you've got multiple other elements. So we see bolted joint failures due to only transverse influences, but also a myriad of influences that we need to kind of take into account.
We also have a lot of customers that there's elements of the joint design you can only apply so much load to that joint, because if you overload the joint, other things go wrong, but you don't want it to come apart. So this would actually affect that in a very positive way as well. So Luke, what are the fundamental principles of the wedge lock washer? What's the magic that makes this washer work? Explain that to us.
Well, if I could
Yep.
reference this, so the wedge lock washer is a two-part system. On the outside, you have serrated edges or radial teeth. The purpose of this is to imprint or to grip into the mating surfaces.
The bearing surfaces.
The bearing surfaces,
Okay.
the material or under the bolt head or under the nut.
Right.
But the magic happens on the inside with the wedges or the ramps or cams.
Okay.
And this is where the angle of the cams or the wedges is greater than the angle of the pitch thread of the bolt.
Okay, all right, so I'm gonna reiterate that. So we have wedges that have a height to them, right, on the high side of the wedge, and you're saying the height of that wedge exceeds the pitch length of a thread.
Yes, that angle that's formed, the geometric angle, is
Right.
greater than the pitch thread. And so as that bolted joint is being influenced by a loosening potential or
Right.
loosening force, the wedges act against each other and actually expand the two-part system,
Okay.
which increases preload and prevents the bolt from coming loose.
Very good. Now, you talk about it imprinting on the bearing surfaces, so that washer must be very hard.
Yep.
And we have property class 10.9, 12.9, or we call grade 8, or ASTM A574 socketed cap screws that are up at about HRC 45. I know you call this out in Vickers, and that exceeds HRC 45. Is that correct?
That's right. That's right.
So it'll work on those high
Yeah,
hardness
it's
fasteners.
485 Vickers, and that translates to about 50 HRC.
That's right.
So.
That's
Okay.
right.
All right.
So it's critical because if the serrated teeth can't imprint or can't grip into the bearing surfaces,
Right.
then it will not function.
Right.
But you addressed it earlier. Class 12.9, grade 10 and below, this will definitely be harder than
And
those
it'll work
surfaces.
Than those
Okay,
surfaces,
good to
yeah.
know. Very, very good to know. Okay, so that's kind of the magic behind how this works, right?
That's right.
Okay, so you brought a test unit. We're going to put this to the test and test it against some other elements of locking and see how it works. All right, let's go over to
Let's
the
get
test
excited.
unit. All right.
All right, Luke, so what are some of the locking methods we use to maintain bolt preload?
Well, the most common you see in the market are the friction-based lock washers and lock nuts. Interference-based, just a huge variety of those that traditionally have been out in the market.
Right.
And generally speaking, there are some appropriate applications for those, but for critical bolted joints, we've generally found that the bolt's not going to retain the proper preload to keep that joint tight with a lot of the friction-based lock washers or lock nuts. Secondly, you have some thread lockers and thread adhesives. And
We do, and by the way, so Luke, we did a episode on lock nuts. So if you haven't watched our episode on lock nuts, please make sure you watch that. because that really does coincide with the retention, what we've done. In addition to that, you just mentioned the thread lockers. So stay tuned. We have an upcoming episode on pre-applied adhesives and liquid adhesive thread lockers too. So that's important to understand as well. But this goes beyond that.
That's right, that's right. So in addition to the thread lockers, you have geometric interference type fits. You have like dowel pins and locking tabs.
Correct.
You also have locking wire. That's something that you see out
Yeah,
in the
safety
field.
wire.
Safety
That's where
wire.
they actually drill through the heads of bolts and apply the safety wire through the heads of bolts. Yeah.
So we've seen that that method, the interference type methods, just aren't appropriate to maintaining preload under extreme conditions.
Right, so you brought a machine with you today, and we're going to put this to the test and make you prove what you say.
That's right, that's right. And I'm
Talk about
very
this
glad
machine.
to do it. And of course, the last locking element is the tension-based locking element.
Gotcha.
And that's
Okay.
that's generally the wedge lock washer family
Okay.
bolt retention.
All right.
So what do we have lined up here, Luke? Can you tell us?
So what we're looking at here, it's a demonstration of a Junker machine. And a Junker machine is simply a method that's globally recognized for testing the appropriateness and assessing the performance of a locking element in terms of maintaining bolted joint preload.
So it is a recognized consensus standard on how to conduct this test.
That's right, that's right. But the fundamentals are the same. You have two plates that move transversely.
Okay, like this, all right.
And then it replicates extreme vibration that we've talked about previously. That shows without a doubt the performance effects of any number of type of locking elements.
Okay.
And so our plan here is to take just a regular bolted joint, just a hex nut itself. Then we're going to take a hex nut with a split lock washer. We see that a lot.
Okay.
And then also with the nylon insert. And then finally proven the wedge lock washer.
The wedge lock washer.
All right.
And then this machine, I see the screen here, it graphs this.
It does. It does.
So we're graphing what?
So you're graphing preload over
Okay.
time.
All right. So for this machine, what preload are we applying here?
We're about a little over 14 kilonewtons.
Kilonewtons. Okay, 14 kilonewtons. We'll do every one exactly the same, and then we'll be showing you the graph results on this as well. Now, before we get started, we always have to make sure we maintain our safety. So here's our safety glasses, just in case anything does go haywire. And we're going to start with just a regular finished hex nut on a hex cap screw.
Yep.
Correct?
First test.
Okay, so what do we do here? How do we get this machine
Here we go.
going?
Well, I've got the first test element set up. So as you can see, there's an index line here that will visually show the bolt loosening or maintaining its
Physically see it
preload.
loosen.
Mhm.
All right,
So
very
we'll,
good.
We'll start with the first test here.
There it goes. Yeah, you can see it turning.
Wow, that didn't take very long for that to rotate. And okay, and that's common. That's what we see all the time.
That's
All right, let's set up our next one. All right, so to run our next test, we're going to do what is known as a helical lock washer. Also, some people call them split lock washers. Now, these are really improperly used very, very frequently. So I'm really happy, Luke, that we're doing this test today. So you already have that set up on there. You have a helical split lock washer on there. Let's show the audience how effective these really are. So I'm happy that you're doing this today. So thank you for that. Let's run this one.
Okay, let's run it.
Oh, wow. Boy, it just right out of the gate dropped right out, saw that line move.
No different than the regular hex
No
nut, did
different,
it?
hardly.
Yeah, so that's that transverse movement that we're talking about. These helical lock washers don't do anything for. They'll take axial movement, but they do nothing for transverse movement. As a matter of fact, they'll make it worse sometimes. Important to understand. Let's go to our next test.
Okay.
Yeah. So we talked about nylon insert lock nuts in our last episode, and this is exactly what we have here. So let's start the test.
Yeah, let's get it going.
Yeah, look at that thing go. Yeah, it drops so fast. There it is again, Randy.
Okay, nylon insert lock nuts. Again, that's that transverse high vibration. It's an extremely severe test. So it's a good lock nut, but this type of severity, It's a little bit too much for it.
Yeah, it sure is.
Okay, let's go to the next one.
Yeah, let's go to the next one.
Okay, Luke, this is our final test. What do you got?
Well, it's the pièce de résistance of the whole deal here.
Okay.
So we got a wedge lock washer set up, ready to be tested, and let's go.
I'm excited. Oh, we're going to prove this thing out.
And just a nice flat curve, man.
And that's exactly what we want. What does the index lines look like, Aaron?
I don't know that I can barely tell that thing move, so.
So high, transverse vibration, the wedge lock washer. Now, Luke, I have an application that, here's the funny thing. I've known about this for years, but I'm like everybody else out there. One, I don't have a big torque wrench, but I got a problem with my tractor, and I need you to resolve it for me.
Well, let's take a look at it.
Let me pull the tractor in, and let's look at that application.
Perfect.
Okay.
Perfect.
Okay, we've pulled the tractor into the shop, and I'm excited about it. Luke, you're going to solve my problem. Now, first of all, let me tell you what's going on. We have here what's known as a draw bolt. The draw bolt is what goes on the mower deck, and it hooks to the 3-point hitch, and it lifts the mower deck. You'll see here it comes with a helical lock washer, and this comes loose on me all the time. So as an example, Luke, I have here one that broke on me the other day. So again, the helical lock washer, the nut, and the pin, and it broke out in the field. Now, typically, Luke, this is not a critical application, but
For you, it is a critical
it's
application.
critical. Ask me this question in 100-degree Texas temperature, and I'm out in the field cutting this off with a hacksaw.
That's critical.
So let me do this. We have the one that I replaced it with down there, and as a matter of fact, as I look at it, that one's already loose. Let me take this apart and show you the full assembly.
Okay.
Okay, we've taken the draw pin out, and Luke, look at what happens here. So to put it in my Uncle Mo's terms, I've wallered out the hole. And this is what happens when these pins get loose. They start moving and they'll waller out the hole. So Luke, what's your solution?
Well, Randy, this is certainly in a large hole. It is wallered out completely.
It is.
So normally our standard wedge lock washer would suffice, but for this application, I think what we need to do is use the enlarged diameter wedge lock washer, which is designed for elongated holes, enlarged holes, and this is the perfect application to help you with this.
Okay, so explain to me then the technology that's going to work in this assembly.
Well, like you saw in the demo, under a lot of transverse forces, this will remain tight and keep the preload of the bolted joint. Looking at where you use this piece of machinery, there's a lot of vibration, and I guarantee you there's a lot of shock load in a day's work. So this will certainly help mitigate any bolt loosening.
Okay, so the wedging action on these lock washers exceeds then the distance of my threads on my bolt.
That's right.
Okay.
That's right.
So, so then what? I put one underneath then what would be the head of this particular part, and put it through. We'll put this back together, and that goes on the other side. So we use two of them, one on each side, one against the nut, and one against the other side on the head.
Perfect.
And that fits on there perfect. So let's put this joint back together.
Let's do it.
All right. Luke, this is fantastic. That large OD covered up my wallered out hole, and this looks like it's really snug and tight. It's going to stay together?
It will stay together. The tension-based wedge lock washer is what's going to be the answer to your problem, and you can drive on with confidence.
Thank you very much. This will solve a lot of problems for a lot of people in all industries. So in conclusion, the wedge lock washer is excellent in many diverse applications, but first, Luke, you say this comes in some different configurations.
It does.
Explain the configurations to us.
Well, we've already gone through the standard diameter and the enlarged diameter wedge lock washers previously.
Right.
So we have, and of course, the wedge lock washer has been out in the field for 40 or so years. So it's, so there have been some nuances. There's been some developments. The first one would be the wedge lock nut. This is basically a K assembly.
Okay.
And what it does, it permanently attaches the wedge lock washer to a nut body, which provides a lot of efficiencies in production. You don't have two parts, you have one part. It's been really well accepted here in North America.
Excellent. One good. Two-part numbers into one.
Yep. And the most recent development with the wedge lock washer technology is HEICO's Combi washer. Now the Combi washer does two things. There's an inner polyamide ring that keeps the two washer halves together,
Okay.
which is great. And then also there's 3 locking tabs on the inside of the ring,
Okay.
which keeps the washer attached in a semi-permanent fashion to the shank or the threads of the bolt.
Oh, wow.
So that's been really good and also introduces some efficiencies in production. And now the field, you have 2 parts, now you have 1 potentially.
And you're not
Outstanding.
losing parts, which
And
is
we're not
great.
losing parts when
Yeah.
you take them apart. Absolutely, especially when I'm working on my tractor in the field.
So it's been very well received. But in addition to that, you know, all the wedge lock washer come in either a carbon steel. There's a 316L stainless.
Okay.
Then you have 718 Inconel.
Yeah,
And
yeah.
254 SMO. So and some other exotics as
For
well.
high corrosion applications. Okay,
Absolutely.
very good point. So outstanding. So a lot of opportunities on these wedge lock washers.
Yep, and you've got, you know, some of the benefits we have from this. We're eliminating slippage due to the transverse loading.
That's right. Everything's about maintaining preload. And so if you stop that slippage potential with preload, the joint will not come loose.
Right, unforeseen shock like we saw on Randy's tractor.
Unforeseen shock.
Well, they can certainly have an impact. So this technology really mitigates the effects of that.
That's right. All right.
So even with low-end preload, the wedge lock washer gives you assembly security. I want to thank HEICO and thank you, Luke, for being on the show today and teaching us about this outstanding technology that I believe is going to be good for many applications.
Aaron, Randy, you're very welcome. And thank you both too.
Our pleasure.
Thanks.
High vibration, critical applications, use wedge lock washers. That's worth knowing. I want to give another special thank you to HEICO Fastening Systems and Luke Reed for their assistance on the show today.
Yep. Hey, shake it on up. Leave us a comment.